Solving for an unknown angle in a right angle triangle. Just a quick recall. If we had angle B here as our working angle, we are going to label the hypotenuse, adjacent, and opposite based on our working angle. Across from the 90 degrees, we always have our hypotenuse. This is the side across from the 90 degrees. We have angle B here, the working angle, and across from angle B is the opposite. Across from. Then we have the remaining side, which is the adjacent. And the adjacent is the side that's between the working angle and the 90 degrees. Now let's talk about the inverse operation. If I had this equation, 3x is equal to 15, in order for me to solve, I would have to divide by 3. How do I know I'm dividing? I look at the 3 and I see that 3 is being multiplied to the x. So in order for me to undo it, I need to do the opposite. And the opposite of multiplying is to divide. So for me to solve, I would have x is equal to 15 over 3. Let's look at this example. X minus 7 is equal to 14. What's going on with the x? We have 7 subtracted from the x. So this is subtraction, and the opposite of subtraction would be addition. So when we apply it, we have x is equal to 14 plus 7, and I get the value of x. Let's do another one. If I have x squared is equal to 36, the operation that's being applied to the x is a square. The inverse operation, or the opposite, in order for me to isolate for x, is to get the square root. So I have x is equal to square root 36. We get our answer of 6. Now, when I have sine x, and sine x is equal to 0.7071, sorry, I noticed there's a decimal missing right there. The operation that's being applied on the x is we're taking the sine function and we're applying it to the x. What's the opposite of a sine function? This would be the inverse sine, or you could say arc sine. It's represented by the symbol, sine, and a -1. So for me to undo the sine, I'm going to take the sine, put it on the other side, and we have x is equal to inverse sine of 0.7071. That gives us the x, which is our degree of 45. So let's summarize. What we just did is we did the trigonometric ratio, but the undoing version. When we undo it, we apply the inverse operation. So we have inverse of sine, inverse of cosine, and inverse of tan. And we read it as sine inverse or arc sine, and we'll undo the sine function, and it gives you the angle. So let's look at this triangle. If I have 60 here, I have my opposite and my adjacent. I could say that this is tan 60 is equal to 10.4 over 6.0. Now, if I undid the tan, I would have 60 degrees is equal to inverse tan, or tan inverse, of 10.4 over 6.0. So when you throw this into your calculator, you would get 60. So in your calculator function, if you are using a scientific calculator like the Desmos one, you can go into function and you'll automatically have the sine button and or sine, cosine, and tan inverse. If you are using a phone calculator, you will probably have a button that says second or INV for inverse. If you're using a phone calculator, you're probably also going to need to type in this first and then do your tan, sine, and cos inverse. Okay, so find the inverse trig on your calculator. Let's solve for some of these. So we have find cosine b is equal to negative 0.5. So to undo the cosine, we're going to have angle B is equal to cosine inverse of negative 0.5. Pull out the calculator, cosine inverse, negative 0.5. So it automatically gives me 120 degrees. If I have a fraction, I'm going to keep it the same way, but I'm going to put this in a bracket when I undo the sign. So sine A is equal to 1 over root 2. So we have A is equal to sine inverse of 1 over root 2. So if we're using the Desmos scientific calculator, the nice thing is we can type it in just the way we see it. We get 45 degrees. Great, let's use this now to solve for an angle. Find the missing angle, round to the nearest degree. We have our missing angle here. First thing I need to do, just like when I was solving for a side, I need to identify the sides. The 4 is across from my working angle. I know this is the opposite. The 7 is across from the 90 degrees. So we have our hypotenuse. We also have our menu of trig functions. So I have SOHCAHTOA. If I look at the opposite and the hypotenuse, the only one that involves both of those sides is the sine. So we have sine theta is equal to opposite over hypotenuse. And then to solve, I need to isolate for theta. I have theta is equal to inverse sine of 4 over 7. Let's keep going. We need to use our calculator now. Inverse sine of 4 over 7, 34.84. But it says we need to round to the nearest degree. The First number after the decimal is an 8, and since it's greater than 5, we're going to round the number up. Let's do another example. Find the missing angle and again round to the nearest degree. We have our angle here. We're going to identify the sides. So we have our hypotenuse across from the 90 degrees, and we have the adjacent, which is between the 90 and the working angle. So, toa. I'm going to use cosine because cosine involves the adjacent and the hypotenuse. Cosine theta equals adjacent over hypotenuse. So let's undo the cosine. If theta is equal to cosine inverse of 21 over 24. Cosine inverse of 21 over 24, and we get 28.955. To round to the nearest degree, we're looking at the 9, and we're going to round to 29 degrees. Another example. Find the missing angle and round to the nearest degree. Label the upper angle as A and the lower angle as B. So we have A here and we have B here. Now, since we're given all three sides, we can choose which one to use. We could use sine, cosine, or tangent, as long as we're labeling what's relative to our working angle. So if I'm using angle A, 12 is my opposite, and 15 is my hypotenuse. So if I'm interested in using the hypotenuse and opposite, then I have to use sine. Sine A is equal to opposite over hypotenuse. Now to undo the sine, I have sine inverse of 12 over 15. Let's throw that into the calculator. 12 over 15, and we have 53 degrees. Now, if I decided to use cosine instead, but and then I used cosine is equal to 9 over 15, I should get exactly the same answer. It's just that I'm using two different sides. The ratios are always going to give us the same thing. Now let's look at angle B now. I'm going to use the red to represent angle B. So for B, this is my hypotenuse again, but this time, this side is my adjacent. So if I used adjacent and hypotenuse, that would be my cosine. So we have cosine B is equal to adjacent over hypotenuse. Let's undo the cosine. Cosine inverse of 12 over 15. And we get 36.8. Let's round that to 37 degrees. Now, another way we could have gotten angle B is if we subtracted, because we know that at this point, A is equal to 53 degrees. If we know A and we know the 90 degrees, then I can find B. I would take 180 minus 90 degrees minus 53. And when we subtract it out, we get 37. So, two different ways to get to the same answer. One was a bit simpler, and this was a more complicated way. Example, find sine r, and then we can find the missing angle if we want. Let's draw the diagram. Draw PQR where Q is 90 degrees, P is 10, and R is 5. Now we remember that capital letters represent the angle. So we have angle Q here. Across from angle Q, we have little q. We also have big P, and the corresponding side is 10 centimeters. The last angle we have is R, and the corresponding side is 5 centimeters. Now, since we're asked to find sine R, we're not quite there yet because we know that sine R is equal to opposite over hypotenuse. But the trouble is we don't have the value for our hypotenuse. We know that it's little q, but that's not enough. So let's use Pythagorean relation now to help us find the hypotenuse. Right? We have 5 squared plus 10 squared is equal to q squared. 25 plus 100 is equal to q squared. Q squared is equal to 125. And if we undid the exponent, we're going to put 125 inside the square root. So let's substitute it in here. Square root of 125 is equal to 11.1. Now that we have the value of our q, we can substitute it into our equation. Equation says sine r is equal to opposite 5 over 11.1. We have answered this question. We found sine r. Now, if I was looking for angle r, I could have done that without looking for sine r. I could use the r and the p if I had tan, but now I can also use sine for me to find angle r. R is equal to sine inverse of 5 over 11.1. Let's put that into the calculator. Sine inverse of 5 over 11.1. And we have r is equal to 26.7, rounded up to 27 degrees. Slides number 12, 13, and 14, I'd like you to try this on your own. We'll take this up in a moment. Right, solutions for our try this question. The first one, the second one here, and our third one.